Hello, you're welcome to today's lesson. That is Theorem 5. And today what we're going to talk about is called tangent. We're going to deal with something we already know. With this theory, we're going to talk more on tangent. And with the tangent, it will help us to develop our theories. Then, what is a tangent? What is a tangent? T-A-N-G-E-N-T. That is a tangent. Now, when we talk of tangent, we simply means any line drawn to touch a curve at a point. Any line drawn to touch a curve at a point, but it does not crosses it. Take note on that. Any line drawn to touch a curve at a point crosses the curve. So it's this definition that is going to help us deduce our theorems that are left. So what does the theorem 5 says? The theorem 5 says that the angle between a tangent and a radius is 90 degrees. The angle between a tangent and a radius is 90 degrees. In a nutshell, what does this theorem say? If you look on the screen, if I have a circle like this, they said a tangent is any line drawn to touch the curve. So if I have this circle and I draw any line, have you seen this line? That is a tangent. A line drawn to touch the circle at a point. So assuming this is our point, so this line becomes a tangent. The tangent, I will use T for touch. T for touch, which means it touches it, but it does not crosses it. So a line that touches it is called a tangent. So this line is a tangent. Now, according to the theory, it says what? The angle between a radius and a tangent is 90 degrees. So it means we should draw our radius. This is our center. So any line drawn from the center to touch other parts of the circle is radius. So when the radius and the tangent meet at a point, they form 90 degrees angle. When the radius and the tangent meet at a point, they form 90 degrees angle. So this angle from here to the tangent line is 90 degrees. At the same time, from here to the tangent line is 90 degrees. Please take note, any line drawn from the center, please take note, when the radius and the tangent meet, they form 90 degrees angle. I can have my tangent in different shapes. I can have one here. Remember, it has touched the curve, so this line becomes our tangent. I can have my radius there too, so that one too, this place is 90, this place is 90, at the same time this one too is 90. Please take note, the 90 comes to touch the curve, so this one too is 90. I can draw as many as I can to have my tangent. All what you're supposed to know is that a tangent is any line drawn to touch a curve at a point, but it does not crosses it. That's very simple. So I can have my radius, and remember, they all form 90 degrees angle. So when you're solving the question, remember this theorem, and it will help you to solve every question. So that is the theorem 5. The theorem 5 says the angle between a tangent and radius is 90 degrees. point the tangent meet the radius is 90 degrees. We are going to solve some examples. Theorem C says that the angle between a tangent and a chord is equal to the angle in the alternate segment. So the key points here, or the key words, are the segment and a chord. Ready for the tangent, we know the meaning. So let's go to the demonstration board and see how best we can demonstrate this theorem. If you look on your screen, we have this circle and there is a tangent line. Now, according to the theorem, you're supposed to have a chord and a tangent, but we have only tangent, which means you're supposed to draw our chord, because that chord will give us the segment, either the minor or the major segment. So I have my chord and I can name it as AB. Line AB will serve as our chord. So taking line AB as our chord, which means this region becomes the minor segment and this region becomes the major segment. Minor segment and then the major segment, if you could remember the introduction that we did. And according to the theorem, it says the angle between the chord and the tangent will be equal to the opposite segment, the angle in the alternate segment. So this is the major segment and this one becomes the minor segment. And according to the theorem, any angle that form either the angle this chord will make with the tangent, if it is in the minor segment, then that angle will be equal to the same angle the chord will make in the major segment. I'm taking it again. The angle this chord called AB will make with the tangent, that is the minor segment, will be the same angle the chord AB will make in the major segment. So first of all, let's take our angle, the angle the chord makes with the tangent at the minor one. This angle will be equal to the angle the same chord will make in the other segment, that is the alternate. So we have this minor segment, we have this major segment. The angle this chord will make with the tangent will be the same angle it will make in the alternate segment. So if you look at this one, the minor segment has this angle and the major segment has this angle. So the angle this chord AB will make with the tangent will be the angle in the opposite side of the segment. I hope it's clear. Now we can have this one too as our chord, taking chord AC as our chord, which means this one becomes our minor segment and the whole of this one together with this colored one becomes our major segment. So the angle this AC, chord AC, will make with the tangent will be equal to the angle it will make here. So that is it. So this angle will be equal to this angle. I'm taking it again. If you should take chord AC, which means this one will be our minor segment and the whole of this one becomes our major segment. So the angle the chord AC will make with this tangent will be equal to the angle the same chord will make in the major segment. So this angle will be equal to this angle. Remember, this angle too is equal to that angle. Now let's go and solve some examples. Now with the theorem 7, it's just like what we've done so far. Remember, we are dealing with tangents. With the theorem 7, it states that two tangents from the same point to a circle are of equal length. We are talking about two tangents. And according to the theory, it says when we have two tangents and they are from the same point, their length are the same. Now I have this circle and I have these two tangents moving from this point. I can name this point as B or any. Now, already we know that anytime a tangent touches the circle, it gives a 90 degrees angle. So we have this one to be 90, this one too to be 90. But according to the theory, it says once they are from the same point, that is this place, they are the same. That is point B. Once the tangents are from the same point, point B, and they touch the circle, remember their length are the same. That is why we have this sign signifying that these two lengths are the same. I'm taking it again. When we have two tangents from the same point, their length are the same. That's why the theorem says that two tangents from the same point to a circle are of equal length. This is 90 and this one too is 90, which means the opposite side is supposed to give us 180. Just like what we have here. This one too, the opposite side, point O and then point B, they add up to 180 degrees. This one form a quadrilateral, point A, B, C, O. They form a quadrilateral. So when you sum all their angles up, you should get 360 degrees. So if you look at this one, the opposite angle sum up to 180. So angle A and angle C will sum up to 180. At the same time, angle O and then angle B will sum up to 180. Now let's go and solve some examples under these three theorems we've done so far, and I hope you will get the understanding much better. Okay, now let's solve these examples. Find the value of the related angles x, y, z. Pause the video and see if you can work for the unknown letters. These are the answers. Check it and see. Did you get it correct? If no, try doing more and you'll get it. Thank you once again. See you in my next episode. Bye-bye. Thank you very much for watching. This is Sir Cosmos, your 21st century teacher. See you in my next episode. Bye-bye.